This is day 7 of Advent of Cyber 2024, and this challenge is called Oh No, I'm Speaking in CloudTrail, Monitoring in an AWS Environment. Care4ware's infrastructure runs in the cloud, so they chose AWS as their cloud service provider. Instead of their workloads running on physical machines on premises, they run on virtualized instances in the cloud. These instances are, in AWS, called EC2 instances, Amazon Elastic Compute Cloud. A few members of the Werewolf SOC aren't used to log analysis on the cloud, and with a change of environment comes a change of tools and services needed to perform their duties. Their duties this time are to help Care4wares figure out what has happened to the charity's funds. To do so, they'll need to learn about an AWS service called CloudWatch. CloudWatch is a monitoring and observability platform that gives us greater insight into our AWS environments by monitoring applications at multiple levels. CloudWatch provides functionalities such as the monitoring of system and application metrics and the configuration of alarms on the metrics for the purposes of today's investigation. Though we want to focus specifically on CloudWatch logs, running an application in a cloud environment can mean leveraging lots of different services, e.g. a service running at the application, a service running functions triggered by the application, a service running the application backend, etc. This translates to logs being generated from lots of different sources. The CloudWatch logs make it easy for users to access, monitor and store the logs from all these various sources. A CloudWatch agent must be installed on the appropriate instance for application and system metrics to be captured. A key feature of CloudWatch logs that will help the Werewolf SOC squad and us make sense of what happened in the environment is the ability to query application logs using filter patterns. Here are some CloudWatch terms you should know before going further. So there are log events. A log event is a single log entry recording an application event. These will be timestamped and packaged with log messages and metadata. Log streams. Log streams are a collection of log events from a single source. And log groups. Log groups are a collection of log streams. Log streams are collected into a log group when logically it makes sense. For example, if the same service is running across multiple hosts. CloudTrail. CloudWatch can track infrastructure and application performance, but what if you want to monitor the actions in your AWS environment? These would be tracked using another service called AWS CloudTrail. Actions can be taken by a user, a role granted to a user given them certain permissions, or an AWS service and are recorded as events in AWS CloudTrail. Essentially, any action the user takes by the management console or CLI or service will be captured and stored. Some features of CloudTrail include it's always on, CloudTrail is enabled by default for all users, JSON formatted, all event types captured by CloudTrail will be in the CloudTrail JSON format, event history. When users access CloudTrail, they'll see an option, Event History. Event History is a record of the actions that have taken place in the last 90 days. These records are queryable and can be filtered on attributes such as resource type. Trails. The above mentioned Event History can be thought of as the default trail, included out of the box. However, users can define custom trails to capture specific actions, which is useful if you have bespoke monitoring scenarios you want to capture and store beyond the 90-day event history retention period and deliverable. As mentioned, CloudWatch can be used as a single access point for logs generated from various sources. CloudTrail is no different and has an optional feature enabling CloudTrail logs to be delivered to CloudWatch. As mentioned, CloudTrail helps capture and record actions taken. These actions could be interactions with any number of AWS services. For example, services like S3, Amazon Simple Storage Service used for object storage, and IAM, AWS's Identity and Access Management Service, can be used to secure access to your AWS environment with the creation of identities and the assigning of access permissions to those identities. We'll have actions taken within their service recorded. These recorded events can be very useful when performing an investigation. Intro to JQ. What is JQ? Earlier, it was mentioned that CloudTrail logs were JSON formatted. When ingested in large volumes, the machine-readable format can be tricky to extract meaning from, especially in the context of log analysis. The need then arises for something to help us transform and filter that JSON data into meaningful data we can understand and use to gain security insights. That's exactly what JQ is and does. Similar to command line tools like sed or congrep, JQ is a lightweight and flexible command line processor that can be used on JSON. So, how can it be used? Let's look at how we use JQ to transform and filter JSON data. The wares being the wares, they stored their shopping list from the trip to the bookstore in JSON format. Let's take a look at that. So we have a list, and each item in the list is an object where there's a key book title, genre, and page count. JQ takes two inputs, the filter you want to use, followed by the input file. So we start our JQ filter with a dot, which just tells JQ we are accessing the current input. From here, we want to access the array of values stored in our JSON with the square brackets. So making our filter dot square. So for example, if we ran this, we would be given each of the items in that list. Once we've accessed the array, we can grab elements from that array by going one step deeper. For example, we could run this command. So going through the list, we are grabbing the key book title, and we've now got the output of the values for those keys. That's a lot nicer to look at, isn't it? It gives you an idea of what JQ is and what it does. Of course, JQ can filter and transform JSON data in many additional ways. In our upcoming investigation, we'll see the tool in action. The peculiar case of Careful Where's dry funds. Now that we have refreshed our knowledge of AWS CloudTrail and JQ alongside Mosquitty, let's investigate the peculiar cases of Careful Where's dry funds. The responsible for Careful Where's charity drive gave us the following info regarding this incident. We sent out a link on the 28th of November to everyone in our network that points to a flyer with the details of our charity. The details include the account number to receive donations. We received many donations the first day after sending out the link, but there were none from the second day on. We talked to multiple people who claimed to have donated a respectable sum. One showed his transaction, and I noticed the account number was wrong. I checked the link, and it was all still the same. I opened the link, and the digital flyer was the same except for the account number. McSkitty recalls putting the digital flyer, Wareville Bank Account QR PNG, in an S3 bucket called Wareville Cares. Wareville Cares for Wares. Let's assist McSkitty and start by finding out more about that link. Before that, let's first review the information that we currently have to start the investigation. Today the link was sent out, several donations were received. Since the second day after sending the link, no more donations have been received. A donor has shown proof of his transaction. It was made 3 days after we received the link. The account number in the transaction was not correct. McSkitty put the digital flyer in the AWS S3 object named Wareville Bank Account QR.png under the Wareville Careful Where's. The link was not altered. So for this challenge, we will start the VM and it will open up in split screen view. So let's go back to where we were. Glitch did it. Let's examine the CloudTrail logs related to the Wareville Careful Where's S3 bucket. For a quick example, a typical S3 entry looks like this. So you have all this information, each log. So this is an entire log. You have user identity, so you have the user which accessed it. You have the time of event, they accessed S3. They did it in AP Southeast 1. They accessed AUC CloudTrail Wareville bucket. And what they did on the S3 was they list the objects that are in the bucket. So by using the guide above, we can read the example log as follows. The IAM user, Wareville collector, listed all objects of the S3 bucket named AOC CloudTrail Wareville. The IP address from which this request originated is 334.247.218.56, and the user agent indicates that the request was made using the AWS SDK tool for Go. Now that we know where to look, let's use JQ to filter the log for events related to the Wareville bank account QR.png S3 object. The goal is to use the same elements to filter the log using JQ, and format the results into a table to make it more readable. According to McSkitty, the logs are stored in the Wareville logs directory. So we'll bring up the terminal. We will cd to Wareville logs, ls, and we've got the CloudTrail logs there. So we'll be running JQ on it. So according to this, the format would be .records and then which is a list, and we will be selecting where the event source is equal to s3.amazonaws.com and the .request parameters .bucket name is equal to Wareville-care for where's, and we are doing this from the CloudTrail logs. So I've got a large list of stuff here. So I want to go to the top and we're just going to quickly look through. Okay, so this username glitch, they listed the objects. Username glitch, list objects, username glitch. So as you can see in the command output, we were able to trim down the results since all the entries are from S3. It's still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields. Execute the following command. So we've got our select, and then we do another pipe, and this will be .event time .event name .user identity .user name, and it's 2// and .request parameters .bucket name. Okay, so we've now got that all entered in. So let's run it. Okay. Ooh, so list objects, this is 1128. Then glitch did a put object, so that seems like he changed it. Okay, well, we've now got another whole thing like this. I'm not going to type it out again, so we'll put it into paste, and we will paste it into the console, and we now have it in a table. So we know that glitch accessed it each time, except for this one where there's NA, where it's unknown. but we know that he put the object in there. So our crafted command line lets us summarize S3 activities from a CloudTrail log. Now that we have crafted a JQ query that provides a well-refined output, let's look at the results and observe the events based on the columns. We can answer the following questions to build assumptions. So how many logs are related to the bucket? There were 5. Which user initiated most of the logs? Glitch did. Which actions did the user perform based on the event field? They were listing the objects in there, then they put an object in there. Were there any specific files edited? The bank details one was changed. What is the timestamp of the log entries? November 28th. What is the source IP of the log? 5394200169. So looking at the results, 5 logged events seem related to the wearable careful where's bucket, and almost all are related to user glitch. Aside from listing the objects inside the bucket, the most notable detail is that the user glitch uploaded the file on November 28th. This seems to coincide with the information we received about no donations being made 2 days after the link was sent out. McSkitty is sure there was no user glitch in the system before. There's no one in the city hall with that name, either. The only person that McSkitty knows with that name is the hacker who keeps to himself. McSkitty suggests that we look into this anomalous user. McSkitty wants to know what this anomalous user account has been used for, when it was created, and who created it. Enter the command below to see all events related to the anomalous user. We can focus our analysis on the following questions. What event types are included in these log entries? What is the timestamp of these log entries? Which IPs are included in this log entries? And what tool OS was used in these log entries? So we'll copy the command, paste it into here. The result shows that the user glitch mostly targeted the S3 bucket. The notable event is the console login entry, which we don't see. Did I mess up that command? Okay, there we go. So we run that, and we can see glitch. So event time, event source S3. We can see mostly targeted the S3. There was a sign in. So the notable event is the console login entry, which tells us that the user account was used to access the AWS management console using a browser. We still need information about which tool and OS were used in the request. Let's view the user agent related to these events using the following command. So we'll now grab this one. User agent, Mozilla on Macintosh. So there are 2 user agent values included in all log entries. There is S3 console, AWS internal, and there's Mozilla Macintosh. An experienced attacker can forge these values, but we should not dismiss this information. It can be valuable when comparing different log entries for the same user. We will park the current information for now. Let's gather more information to connect the dots. The next interesting event to look for is who created this anomalous account. We will filter for all IAM related events, and this can be done by using the select filter .event source IAM Amazon AWS.com. So let's execute the command below and try to answer the following questions. What event names are included in the log entries? What user executed these events? And what is this user's IP? So we will copy this, paste it here, then paste into here. So we see McSkitty has been doing things, and it seems like only McSkitty has been doing things. So based on the results, there are many list policy events. By ignoring these events, it seems that the most significant IAM activity is about the user McSkitty invoking the create user action, and consequently invoking the attach user policy. The source IP where the requests were made is 53.94.201.69. Remember that is the same IP the anomalous user glitch used. So let's have a more detailed look at the event related to the create user. So I'll put that command in. Based on the request parameters of the output, it can be seen that it was the user McSkitty who created the anomalous account. Now, we need to know what permissions the anomalous user has. It could be devastating if it has access to our whole environment. We need to filter for the attach policy event to uncover the permissions set for the newly created user. This event applies access policies to users, defining the extent of access to the account. So we'll now filter based on the attach policies event. McSkitty is baffled by these results. She knows that she did not create the anomalous user and did not assign the privileged access. She also doesn't recognize the IP involved in the events and does not use a macOS. She only uses a Windows machine. All this information is different to the typical IP address and machine used by McSkitty, so she wants to prove her innocence and asks to continue the investigation. McSkitty suggests looking closely at the IP address and operating system related to all these anomalous events. Let's use the following command below to continue with the investigation. So we'll copy that. Based on the command output, 3 users, McSkitty, glitch, and Mayor malware were accessed from the same IP address. The next step is to check each user and see if they always work from the IP address. So let's focus on each user and see if they always work from the IP. So we grab this command, put it into here, we paste it in, and then we need to change the username. That's placeholder. So let's go to McSkitty. Okay, that's a different IP address. We've got 31.210 and then changes to 53.94. That makes sense. So based on the results, we have proven that McSkitty uses a different IP address before the unusual authentication was discovered. Moreover, all evidence seems to point towards another user after correlating the IP address and user agent used by each user. Who do you think it could be? McSkitty has processed all the investigation results and summarized the details below. The incident starts with an anomalous login with the user account McSkitty from IP 53.94.201.69. Shortly after the login, an anomalous user account glitch was created. Then the glitch user account was assigned administrator permissions. The glitch user account then accessed the S3 bucket named Whereville Careful Wheres and replaced the image with a new one. The IP address and user agent used to log into the glitch McSkitty and Mail accounts were the same. The user agent string and source IP of recurrent logins by the user account McSkitty are different. So McSkitty suggests gathering stronger proof that the person who was behind the incident. Luckily, Whereville Bank cooperated with us and provided their database logs from the Amazon RDS. They also mentioned that these are captured through their CloudWatch, which differs from the CloudTrail logs as they are not stored in JSON format. For now, let's look at the bank transactions. So let's look at grep insert rds.log, and we can see there's a bunch of insert queries towards malware with money being added to the account. So the Carefulwares fund received all the donations until it changed into a different account at a specific time. The logs also reveal who received the donations afterwards, given the account's owner's name. With all these findings, McSkitty confirmed the assumption made during the investigation of the S3 bucket, since the sudden change in bank details was reflected in the database logs. The timeline of events collected by McSkitty explains the connection of actions conducted by the culprit. So this was the last donation received by Carefulwares, the bank details updated on S3, and the first donation received by Malware. So now finally onto the questions. What is the other activity made by the user glitch aside from the list object? Was it put object? Put object. What is the source IP related to the S3 bucket actions of the user glitch? So if we scroll back up, it's this IP address starting with 53. So 53.94.201.69. Based on the event source field, what AWS service generates the console log event? That is signin.amazonaws.com. Where did the anomalous user trigger the console login event? Oh, when? That is this here. Oh, no, that's for McSkitty. We need to find the command which looks at glitch. So I see console sign in here. Let's see if that's the correct one. So 2024-11-28T15:21:54Z. That's the correct answer. What was the name of the user that was created by McSkitty? That is glitch. What type of access was assigned to the anomalous user? Let's go back to the permissions. Let's go back to where the permissions were added. So that's attached user, and let's try to find it. And he was given administrator access. So administrator access. So what IP does malware typically use to log into AWS? It's the same one as the activity we saw, so 53.94.201.69. And what is McSkitty's actual IP address? So we need to find that command again. So right there, and it is 31.210.15.79. What is the bank account number owned by malware? Let's find that RDS grep. His account number is 2394691277231294. Cool, and that is the last question for this challenge. So that is day 7 of Advent of Cyber 2024 completed. If you like this video, make sure to like and subscribe.